Hi, this is Tyler recording for question number 5 for 2013 AP Calculus PC. This one is basically asking me to get anti-differentiating dy dx equals y squared parenthesis 2x plus 2 parenthesis. But question A is kind of asking different thing. It asks me to get a limit when x approaches 0, fx plus 1 over sine x. Well, we know that sine x is gonna be equal to 0, approaching to this 0, and we know that fx when x equals 0 is negative 1. Therefore, if fx is continuous when x is approaching to the 0, it's gonna be approaching f0, which is negative 1. Therefore, negative 1 plus negative 1 plus 1 should approach 0. This is 0 over 0 form for L'Hopital's rule, and I want to write it down as this way. I'd like to write it fx plus 1 approaches 0, whether I'm not sure if it's approaching from negative or positive, I don't really care. And when excuse me, sine of x is approaching 0, it's also gonna be 0. So I'm just writing down L'Hopital's rule, and hopefully when I differentiate fx plus 1 and sine x, we'd get something else. Okay, so I write h above the equation, equal sign, x approaches 0, cosine x dividing. Right now we know that f prime x, because dy dx is given as y squared parenthesis 2x plus 1. In this case, equals when x is 0, because x is approaching 0. As we talked about, for fx, f prime x would also approach to f prime 0, cosine 0. And in this case, we have cosine 0, which is 1, which is not 0, and we also have f prime x, f prime 0, which could be 0, but which is not 0. In this case, I plug y square value in times x. 2x plus 2 equals 2. Alright, that was for A. Okay, part B asked me to get use the Euler's method to get f value for x equals 1 over 2. And it wants me to use 2 steps, which is gonna be 1/4, equal size of 1/4 twice. So applying the first step, I have the slope at f equals 0, which is gonna be f prime 0 times the displacement of x, which is 1/4, and plugging in, this is gonna get me negative 1/2, and we're gonna use write that value to approximate next step, f 1/4 plus f prime 1/4 1/4. A lot of 1/4s. So it's negative 1/2. We just got it. Negative 1/2 squared to. It's all plugging in. When you put into the calculator, you get negative 11 over 32. Okay, last part is the gem. It asks me to find y equals fx. So we need to anti-differentiate or integrate. So I want to separate the variable, which is gonna get me 1 point for sure, which is super easy. You just put y in the dy side, x in the dx side. It doesn't really matter if dx goes to the if y goes to the denominator or numerator side. So dy dx is given as y squared to 2x plus 2, and dy over, I want to put y squared on the left side, dx is gonna come right on the right side, dx 2x plus 2, excuse me, those are 2, and keep working on it. Just integrate. I don't need a boundary, just 1 over y squared dy equals 2x plus 2 dx. This is gonna happen because we know we know 1 over y squared dy equals 2x plus 2 dx. We know a equals b, then integration of a should equal integration of b plus c, whatever value it is. And then so 1 over y is gonna equal to x squared plus 2x plus c. You can write down c on the left side, on the right side, it doesn't really matter. Plugging those values in for x equals 0, y equals -1. Solve for y. Solve for c, excuse me. 1 over -1 is gonna 1 second please. It's gonna equal to 0 plus 0 plus c. Therefore c is 1. It's a bit little. Okay, we have c value. C is 1. Plug it in to the original function with c. You're gonna get general formula. Y is gonna travel all the way to the right again. 1 over -x squared -2x -1. I'ma just write down -1 over x squared plus 2x plus 1, which is -x plus 1 squared. Thanks for watching, guys. Have a good night.